In the last video, we created 3 tables: users, notes, and tags. And all 3 tables are related. Users create notes, and a note can have tags. But as we mentioned at the end of the last video, there's nothing stopping invalid reference data from being inserted into our tables. So a note could end up referencing a user that doesn't exist, and a tag in the tag table would be able to reference a note ID that also doesn't exist. Foreign keys help us avoid situations like this by protecting what's called referential integrity. A foreign key constraint requires that a value entered into a column already exist in the primary key or other unique key of the table that it references. So a foreign key could be used to ensure that the user that's referenced in the notes table exists in the users table. And we can use a foreign key to ensure that the note ID that's referenced in the note tags table refers to a valid note. Unlike a primary key though, a foreign key column can contain null. Let's first clean up our environment by deleting the playground schema and everything that's within it, and then we'll recreate our tables again, but this time with appropriate foreign keys. And for all that, I'm going to be working in a new script because this script has become quite noisy with a lot of other statements. So I'll go SQL editor, and I'll click new script. And so firstly, let's drop the playground schema and anything that's within it. And we provide the cascade option to ensure that all the tables are dropped. Now let's bring over all of our table definitions from the other script. So I'll bring the users table. We'll paste that in. We'll bring the notes table. And we'll also bring over the note tags table. Okay, those are our table definitions. The first order of business is creating a foreign key on the notes table. And we do this because we want to make sure that the user email that's referenced in the note table refers to a valid user. And the simplest way to do that now is to write references after the column, the table that we're referencing, and the column from that table. So put together, what this now says is that the user email column references the email column in the users table. It establishes the foreign key constraint. You can also create a foreign key with the table constraint syntax. Let's do that for the note tags table. In this table, the note ID references the note that the tag is for, and we're going to use the table constraint syntax like how we've done with the primary key. So we start off writing foreign key. The column references the source table, which is the notes table, and then the column in that table. So altogether now, this creates a foreign key on the note ID column that references the notes table and the note ID column from that table. Let's now go ahead and create that playground schema and run all of these create table statements. So we'll first create the playground schema, run that, and now let's select all of these create table statements and let's just run those all together. So all 3 tables should now be created. Let's check the database navigator to confirm that's the case. Refresh the tables. And there we see users, notes, and note tags. What's quite nice about dbeaver is that we can right-click on that playground schema and click View Diagram, and it will show you that entity relationship diagram between those tables. You can see the lines connecting the tables. Those represent the foreign key relationships that we just established. So there's a line between note tags and notes, and there's a line between notes and users. So those are our 3 tables, each with appropriate primary and foreign keys. Now let's put some data in those tables so we can demonstrate the effect of the foreign keys that we just created. We'll start by creating a new user. So let's grab that insert statement that we were working on in the previous script. Let's bring it over to our new script. Paste it down the bottom, and let's fix it up now. Insert my own details again. Let's run that insert statement, and we now have 1 user. Now let's try to insert a note into the note table that references a user that doesn't exist. So I'll grab that insert note statement, we'll bring that over to our new script, and we'll edit it so that the user email refers to a user that is not in our users table. Previously, this would have worked, but with our new foreign key relationship, we get an error, and it says the insert or update on the notes table violates the foreign key constraint. So the foreign key protects against inserts, and it will also protect against updates or deletes that would leave invalid references. So let's actually go ahead now and create a valid note. So we'll reference Neil at masterywithdata.com. We can run this insert statement. So we now have one user and one note. Watch what happens now if we try to update that email address in the users table. So let's update the users table. We'll set the email to test@test.com, where the email is currently neil@masterywithdata.com. This might be your first time seeing an update statement. Don't worry though, we'll cover them in more detail in the next chapter. All you have to know is that this update statement is trying to update the user neil@masterywithdata.com and change that email address to test@test.com. That would leave us in a position though where we have a note that's referencing a user that no longer exists. And so, as you would expect, the foreign key blocks it. And you would get a similar error if you tried to delete that user. So if you did actually want to update the email address for a user, or delete a user, how would you go about doing this then? There's a couple of different ways. Let's say you wanted to delete the user. What you would end up having to do is writing a script to clean up all the data, making sure that you delete entities from different tables in the right order. For example, you can't delete a user first, but you could delete a note. And of course, if that note had tags, you would also be blocked from deleting the note. So you would need to delete the tags first, then the note, then the user. So if you did want to delete the user, it would be possible to write a script where you ordered all of your delete statements and made sure that you cleaned out everything so that you're never in violation of any foreign keys. For updating, you've got a couple of options. You could drop the foreign keys temporarily, update the values, and then add the keys back. You could also use what's called a writable CTE, common table expression, which I'll touch on in the next chapter, to update all of the tables in a single statement. And there's a few other options as well. SQL actually has a nice mechanism though for updating and deleting records when you've got foreign key relationships. You can tell Postgres, for example, that you want it to cascade any changes through any affected tables. Likewise, for deletions, you can tell Postgres that you want to cascade any deletes through all affected tables. So on deleting a user, any notes that that user created will be deleted, and in turn, any note tags that belong to that note will also be deleted. Let's recreate our tables with these updates. I'll just start by dropping the entire schema again, and now I'll go and update all of those foreign keys to specify that on updates or deletes, I want the changes or deletions to cascade through. So you do that by modifying the foreign key, so let's do that first for the notes table. And as part of the foreign key definition, you can write in on update cascade and on delete cascade. Likewise, I'll do that for the note tags table. Now let's create our schema and all of these tables again. So we run the create schema statement and all three create table statements. Let's insert a user, so we'll run this statement. Let's insert a note, so we'll run this statement. And now that we've finally specified that if a user email changes, that change should cascade through multiple tables, we can finally run this update statement to change the email of the user from neil@masterywithdata.com to test@test.com. Let's run that. And now let's run a select statement to see what changes happened. So let's look at the users table first. And we can see that the email address was updated there to test@test.com. And let's also now look at the notes table. And the user's email is test@test.com. So the change, which was only specified in the users table, cascaded through to the notes table. And now that we've specified cascade delete, you'll see some similar behavior take place there too. So if we delete the user from the users table, And remember that the email is now test@test.com. Let's run this. So the user was just deleted. Let's have a look what the notes table looks like now. It's empty. The deletion cascaded through to avoid violating the foreign key. And you'd get the expected behavior if there were any tags for those notes as well. The updates or deletes respectively would cascade through to that table as well. Some people prefer to avoid using onUpdate or onDelete cascade, just to avoid triggering a large number of changes when they perform any updates or deletes from tables. And they might prefer to use scripts where they manually specify what change occurs to each table. In my opinion though, you shouldn't be afraid to use these options as long as you always keep them in mind that you've set them up and you're consistent about how you use them. Primary keys and foreign keys are just two types of constraints. In the next video, I'll show you a couple of other constraints that you can use to help enforce the validity of the data in your tables.